So we made it about halfway through functions last week. There was homework. We will get to the homework later on. That is pretty much how it's going to be. If you guys have questions, since we almost never have time, it seems, to get through them in class, I'm going to ask that you either post on the page or come and talk to me afterwards, or come to office hours, or we'll try to set aside a little bit of time for it, but we just honestly don't have lots of time for it. So naturally, I don't want that thing. So we're going to just plow on through functions, and then we're going to get through as much of arrays and objects as we can today. So that'll be the main topic for today. Arrays and objects are data structures that we use in many programming languages, and JavaScript treats them in a certain way. So we're going to learn how JavaScript does it. I, of course, am going off of the OK Coders site with the JS Objects Arrays class. That is where this content is. And so again, we have the arrays and objects markdown files. We'll have a homework assignment for this evening. But again, we're starting with the JavaScript functions class. Clicked on the wrong week there. And there's no, I guess that's not it. That's JavaScript functions. There we go. All right, functions. So this is the material that I'm working off of right now. And I believe we got through returning a value from a function and then using the result of a function. Is that correct? Does everybody remember covering that material? So the gist of it was that we know that a function can return a value. So I'm going to launch Node here in my console, just so that I have the REPL, the read a value print loop. And if I define a function, so I say function, some value, I can have it return a value, right? And then when I call that function, so I call a function like that, using its identifier, the name, and then parentheses, it's going to return or evaluate to that result, in addition to whatever else it does. So that's pretty straightforward, I think. We use the return statement to accomplish that, and remember that we can return more than one value from a function. That is, we can call return more than once, although only one of those return statements will ever be executed. So I believe we did cover that. If I'm mistaken, it'll be coming up at some point for sure. So, okay, so we can use this in another expression, right? So if I can then, and it returns a number, I can do things with that number. So this thing gets evaluated 242, and then I can just use it somewhere. So I could add 10 to it, right? And we get 52. And I believe we got so far in our lesson last time, if that sounds familiar. This is not too crazy. So we can use the call to a function in statements. So just like we can use any other expression in a statement, we can use a call to a function in a statement. So I could stick the call to a function in an if statement, like that. So, and then I'll say, let's say less than 100, which it is. And then I could have my if statement do something like console.log, some value is less than 100, close the if statement, and sure enough, that gets logged to the console. So in the order of operations, JavaScript will first call a function before trying to evaluate it in an expression, right? Or before using it in that expression. So obviously, JavaScript needs to wait on getting the return value from this function before it can check if it's less than 100. So it does that first, yeah? And you want to be maybe careful with these. If you line up a whole bunch of function calls in an if statement, I believe they get executed from left to right. So if one of your function calls is depending on another function call from doing something, you want to be aware of the order that you're calling these things in. So, any questions about this? No, I think this is pretty straightforward. Return a value from a function. So, more interesting is passing parameters to a function. So we learned or discussed from the last class that in mathematics we have functions like this. So I'm just going to whip up Sublime and write out a mathematical function here. So I could have f of x, right? F of x might be a function in math, and f of x is equal to 5x plus 4. If I want to call this function for x in math, I could say like 5 of 1. And so I'm passing 1 to this function. X takes on the value 1, and then 1 is used anywhere that x appears in the expression. And so it would be 5 times 1 plus 4. So f of 1 would equal 9. And you could think of that as being a return statement. If I wanted to write this in JavaScript, I could literally say function f takes x, return 5 times x plus 4, right? That is the equivalent statement. And I can stick it all on one line to make it similar. It's a little more loquacious. But then I would say, okay, well, I want to call this with f of 2. And so now x will take on the value 2, and it will be used in this expression. Yeah, so it would be 5 times 2 plus 4, 10 plus 4 is 14, and so on. So this is exactly like well, mathematics. Yes?
Quick question. Are curly braces required if it is on the same line?
Probably not, but you should always use curly braces and never write your functions on one line anyway. So, although I'm not sure, Milo might know. So it is required. Thank you. Yeah. So, do we get how that works? This is like basic algebra, right? There's nothing really complex about this. The trick is here that we can define a function no longer with just empty parentheses like that. So function something that goes and does something with an empty parentheses. Now we can define parameters to our function. That is the technical term for this. And it is just a name of something that we stick in this parentheses, like x, that will become a variable or a value inside of this function that the function can refer to. Yeah? So it's almost like we've declared a variable x inside of our function, and x will take on the value of whatever we pass to it when we call. We'll get to that in a second. But we don't actually need to explicitly declare the variable. It's almost like we've already done it using that parameter. So we're giving some data name that our function can use. And the general syntax for this is so function name, and then we'll actually say parameters list. That means that we can have more than one item, right? Since we've already seen sort of yeah, let's show you how to do that real quick. So I could say function more than one variable, right? And I could say take x and y. And so now I'm declaring that there will be two sort of named values, x and y, that will be accessible inside of this function. And all I'm doing is separating them by a comma. And so you can imagine if I had a mathematical function like f of x comma y equals x times y plus 1. That is sort of the same thing. If I wanted to use this function in math, I would now have to say f of 1 comma 5. I needed to give it two values. 1 becomes x, or rather x becomes 1, and y becomes 5, and then those are used in the expression. Same thing here, right? I could say return x times y plus 1, or plus 4, or whatever it was, 1. Yeah. So it's like I'm declaring as many variables as I need inside of that function. We call the function, so that's sort of something that I've been saying the whole time. When I've defined a function like this, well, we already know how to call it normally. I would say more than one with parentheses. We sort of learned about that last week. If I want to pass values to the function, so that is what we call that, I give the function arguments. So you define the function, they are arguments when you call the function. And my function has two parameters, so I need to give it two arguments. In other words, I just need to pass it two values or whatever, right? In this case, it's a mathematical function, so I'll give it numbers. And that's a little low down there, so I'll scoot it up something like that. Is that clear? So let's see that in Node, because I'm just doing this in a text file right now. So I could say function f takes two values, x and y. Because I said so, I won't put it on one line. Return x times y plus 1. So I've just defined a really simple function. If I want to call this function now, we know that we could do this, but I need to give it two parameters. So I'll say 10 and 20. And the result, the function evaluates to 201, right?
I have a question real fast. If you go through if you call the function and then it still comes back undefined,
okay.
What is missing there?
Probably the return statement.
The return statement. So you need the return statement.
You must have the return statement, right. So if I did this, so I could have done this. Let's say function g, x of y, x times y plus 1. That's a valid expression in JavaScript. That's a valid statement. It's just going to do x times y plus 1. But that will get sort of locked inside of the function and never be able to come back out of it. You need to return that result from the function in order to get it. So if I call g of 10, 20, as we can see, the result is undefined. That's because it's missing the return statement. You will only ever get in JavaScript, you will only ever get a value from a function if you return it. So that is not the case in other languages. In some languages, the last statement executed inside a function will be the return value.
Which languages are those?
R and Ruby, at least. So I quite like that, actually. But it is not the case in JavaScript. Okay. So we're passing a parameter to some function. So let's look at my function f again. So I would say f of 1 and 2. What if I had a couple of variables? So just to be sure that we're clear that we can do this, let's say var something equals 1, var else equals 2. Else is a keyword in JavaScript, so I can't actually do that. My else equals 2. Okay. And now I could call f, this function, with something and my else, right? These are probably awful names for variables. But the gist of it is, these variables, so when I call this function, before calling this function, JavaScript is going to evaluate the first thing that's going to happen. It's going to work from the inside out, remember? So it's going to see something. It's going to evaluate something to 1, because that is its current value. It's going to see my else. It's going to evaluate my else to 2. And then it is going to call f with the values 1 and 2, right? And so we would get whatever f does. I don't remember. So probably, I think it was x times y plus 1. Is that right? So is that clear what's going on there? So that's really important. We don't just pass variables to the function. In this case, we're going to pass the values. That won't always be the case. For memory reasons, as we see with arrays and objects, it's going to work a little bit differently. Always be aware of the type of data that your function accepts. So I've got this function f, and let's define it again up at the top so we can see it. So function f, actually let's call it foo. Function foo takes x and y, return x times y plus 1. I'm just going to redefine foo so we can see it up at the top. I can call foo with numbers. I can also call foo with strings, as long as I give 2 of them. In fact, I don't even have to give 2 of them. What's going to happen when I do this? I'm going to get not a number. Why do I get not a number?
Strings. You can't multiply 2 strings.
Can't multiply 2 strings. What if my function was this, function bar xy, return x plus y?
That'll work.
Now I can call bar with 2 strings, because strings understand the addition operation. It's called concatenation, remember? That may very well be not what you expect this function to do. So because JavaScript is a fairly loosely typed language, and we can't specify in our function that it only takes numbers or it only takes strings or whatever, it is up to us as the programmer to be aware of what kind of data the function expects and what kind of data the function returns, and to really only ever call that data, right? Now, the author of Eloquent JavaScript mentions pure functions. A pure function is a function that takes a parameter and returns a value based on that parameter, and that is all it does. It does not have what are called side effects. A side effect is when a function does anything else besides value and return a value. So if it prints something to the screen, that's known as a side effect. If it sets a global variable, that's known as a side effect. If it makes a network connection, that's known as a side effect. Anything except for taking a value and returning a value. We like pure functions, one, because they're mathematical, and CS professors love mathematics, but also because a pure function can't cause things to happen in your program that you don't expect. If you always know that the only thing a function does is compute something from a number or a string or whatever that you give it, you don't have to worry about that function blowing out some memory somewhere or setting another variable somewhere or leaving a network connection hanging or whatever, right? In general, we're going to want to try to write our functions so that they don't have side effects. Naturally, that is not always possible. Sometimes we need to print something to the screen. Sometimes we need to make a network connection, and it will make sense to wrap that block of code inside of a function so we can reuse it. But in general, try to avoid that where you can. And so a good example of this would be, let's say I had the function foo again, so function foo, x, y. I could have defined foo to do this. Var result equals x times y plus 1, console.log result, and kill it, right? Console.log is a side effect here. Printing something to the console is a side effect. And so now every time I call foo with any pair of values, it's also going to print those to the console, and then it returns undefined. So we had to be careful there. 201 is the result of console.log. What if I want the same functionality? So I also want a function that does x times y plus 1, or something way more complex, but I don't want it to print to the console. Now I have to completely write another function that does all of those things but doesn't print to the console. I need to take the side effect out of it. When our functions have side effects, we reduce their reusability. And functions, the whole point of functions is to have a block of code that you can carry around and use as many places as possible. So really the right way to do this would have it compute the result and return the result, and then let whoever is calling that function do what they want with the result, such as log or use it somewhere else, right? It's sort of a good practice to have your functions do the minimal amount of work required. They do whatever they say, and that's it. Yes. That does the logging, right? And then that's right. You could compose them, or you could have one call the other, or something like that. So, well, we'll learn about some functional type stuff in a couple lessons here. I hope so. Pretty advanced, so but it's cool. Okay. Now, something that we've been doing here that I've maybe actually just did for the first time, and without it being explicit necessarily, I've used a variable inside of this function, right? So that's okay. I can declare variables wherever I want in JavaScript. I declared var result inside of this function, and I set it equal to this, and I called foo, so that result should have a value in it, right? So what happens if I type result at the console? Reference error. Result is not defined. What do we remember that? Can't find that variable in what's called the scope. And so it can find the variable if we were to say var result equals whatever. It could even be undefined, whatever, var result. I'm just not going to give it any value, but at least result is now defined. Okay? Even though I used it inside of this function, I cannot use it outside of the function. So there is an essential concept in programming known as scope. Scope controls sort of the environment of identifiers that is available at any point in the program. And remember that an identifier is just a variable name or a function name. And so you can imagine that your program has what's called a global scope, where all of the global variables and all of the global functions are available by name. You can call them from anywhere. When you create a new function in JavaScript, so you rather define a function, JavaScript creates another scope for that function, a scope that is private to that function, so that any variables that are declared inside that function are only available in it. It continues to have access to the and global identifiers, but the ones that are in it are private to it. Yeah.
Now, if you returned a result that was within a function, would it then turn with the scope then become global with that?
If I return a result that is within a function.
Yeah. So in foo, for example,
okay.
Returned just result. Okay.
If I just returned result, yeah. I'm not actually returning the variable. I'm returning the value that the variable has, right? And so when in that return statement, remember the first thing that happens in one of the first things that happens when JavaScript is evaluating a line of code that contains variable names in it, those variable names evaluate to their values, and it's actually the value that is used, not the variable. So I could not return result and have result be available. That would not work. I get 6 or whatever it is really. So. This means that we can do some pretty neat things. And so I want to show you this in Sublime in a JavaScript file. So let me quit out of here because we're going to see a slightly larger bit of text. So I'm going to cd into my JavaScript functions directory. Just make a test file and open that guy up. So this is a JavaScript file. So I can say function, say hello to, and then a name, right? And all this function will do is console.log hello plus the name. And then I can have another function say goodbye to, that also takes a parameter of the same name, namely, which is unfortunately a little confusing. And then this one will say console.log hello plus, or actually goodbye, right? plus name. Parameters, like variables, are local to their functions. Name here only has meaning inside of this function. Name here only has meaning inside of this function, right? They are completely separate from one another, even though they use the same identifier. So you can think of the parameters as being added to the local scope whenever that function gets defined and executed. Declare a variable inside of this, so var output equals, and I actually put this expression on that variable and say console.log output. We know that this variable is local to this function, right? So inside of some other function, I can use another variable with the same name. Actually, let me just copy and paste that. And that is totally okay. Those variables are completely independent of one another. They exist in separate scope, right?
And then if you call them in another function, you would have to put the entire function to identify which name you're talking about for both.
If I want to call them from another function,
Just have to concatenate them.
get right up. I'd still have to say, yeah, I have to say hello to Philip, say, plus, oh, I got that right, plus, say goodbye to, and then I have to pass this parameter again to it, right? Is that sort of what you mean? Yep. So name only has reference relative to that function, yeah? And each one takes a parameter. Is that clear what's going on there? And so name outside var text equals name plus, I'll say Mr. plus name. We know that that's going to break. Name does not exist outside of this function, outside either of those functions. Output does not exist outside either of those functions, right? So always be aware of that. There is, for those of you who are programmers and are familiar with other languages, many of you will know that anytime you have curly braces in a programming language, so anytime you do something, enter into a new scope, okay? And so we can think of it, it's like, oh, that works because there's curly braces here. It's like C syntax if you've ever used C or some other language. As soon as you do curly braces, you enter into a new scope. So in other programming languages, if I were to say var output equals and put that statement here, and then do this, put console.log before it, or after it rather, in other programming languages, output would be undefined. In JavaScript, is defined. Output is defined to this variable, okay? If you're coming from another programming language, that is strange. If this is your first time using a programming language, you can think of this as a blessing or confusion. It's probably not confusion since you're not used to it the other way, but this works in JavaScript. That means if I were to make this an if statement, so if true, define var, right? Well, var is going to get defined, but scope only matters in terms of functions. So I'm sorry, output is going to get defined, but scope only matters in terms of functions. So we're going to get output, and output is going to be valid, and that's going to work. That's strange.
It's not going to work, or is it going to work?
That will work. Yes, that's what I'm saying. So it's strange because it's JavaScript. So what that means is the only time we enter into a new scope in JavaScript is when we define a function. Only time. Only time, right? So that being said, what could I do? This will be a little mind trick and a teaser of things to come. What could I do to make it so that I have a second scope, another inside scope, inside this function? Another function. Specifically what? So like, what do you mean?
Just write a new function within it.
Write a new function within it. Function what's up maybe also takes a name and does something with some output. Again, if you're coming from other programming languages, that may look strange. In JavaScript, normal. It is legal to have a function inside of a function, and because this function is scoped to say goodbye to, it only exists inside that function. I cannot use this function anywhere else. It's not global. It is.
Is that a good idea, though, to define functions?
Yes, it is an excellent idea, and it is, in fact, one of the powers of JavaScript.
So you couldn't call what's in
No, I could not.
global scope.
Nope, I can only call what's up from somewhere in say goodbye to. That will work. This will not.
You can't specify that it's part of.
No. Nope. Yes, we have a hand up.
Why is that a good idea to find a function within a function?
It allows me to declare private functions. So functions that maybe have some kind of supporting utility that only make sense in terms of other functions, and then make them only available. So basically, declare a private API. It lets me define functions in terms of the values that I pass to other functions and return those functions. So what do we know about functions? Functions are objects. Functions are values in a sense. Functions are data just like numbers. So I could actually say var, or let's just do this. I could just return that function. Totally legal. Yeah?
And then it would be available in the global scope.
Wouldn't be available in the global scope, not by name, but as a thing that is the function. Remember, I think that's the trick, right? Just like a variable is not the same of its value, a variable only holds a value. Same with a function. A function name is really just a name. It's just an identifier. It holds the actual function, the thing that is the function. It's like a signifier to it. That is what gets returned, not the name. So what would happen here is I'd have to call say goodbye to and assign its return value to something else. And now this thing would become available as new what's up, not necessarily in the global scope, but anywhere after I've declared the variable, right? I saw some hands up. Yes?
Yeah, so the inner function would have access to the outer functions?
Yes. Yeah, so everything out here is still defined in the global name scope, right? Once your file starts executing, anything that is top level, that is not inside a function, is available in the global name scope. Only once you get into a function is it not. So my function what's up inside of say goodbye to could call say hello to. That is totally okay. So welcome to JavaScript. I want to pause questions on this because this is actually gets into more advanced functional programming, which we're going to talk about either in our next lesson or next week. So, but we will learn more about this soon. Mostly, so the critical thing to take home right now is that we have two different scopes. We have global scope and we have local scope. We start with global scope, we enter into local scope with a function definition and when we call it. Where this can get tricky is when we have variables with the same name. So now I have a global variable whose name is output, and I have a local variable whose name is output. I console.log output. Which output is going to get used?
Local.
Okay, but I know you know that. So why does local get used?
Because higher scope definition and yeah, it's more specific scope before the global stuff does.
So more specific scope has priority over the global scope, right? So this output is going to get used. Now you might think I'm just making stuff up here to like tease your brain that this is a pain in the butt. This happens all the time. I'll have some global variable with some name and it's a generic name and I'm going to want to reuse that name in my functions. So I'm just going to use it again. And anywhere that I use that name inside of that function, it's going to choose the local one. That is called masking. I think it's also referred to as shadowing or hiding. Basically, a local variable will sort of like mask the global variable, and any references that use its name will refer to the local variable instead.
But if output's declared or assigned to something, or something's assigned to output rather,
okay,
and you didn't use output inside of say hello to,
so if I got rid of that,
and then you used output in there,
yep, still works.
It would work with the global
That's
variable.
Right. Yep. Because remember, anything has access to, everything everywhere has access to what's declared in the global scope, and here output is declared in the global scope, right? I think even weirder, what if I declared output down here? Is that going to work? And then called say hello, so I call say hello to. I'm declaring output after I declare this function. this is going to work in JavaScript because I don't actually call the function until after I've declared output. So by the time I call say hello to, output now exists in the global scope. But if I tried to call say hello to before declaring output, I'm going to get a reference undefined error because output has not been declared yet. Yeah. Striking weirdnesses, yeah, that you want to be aware of. So this is the semantics of the language. This is just how the language behaves, and we want to be aware of it. So, and again, this sounds like, oh, these are just brain teasers. This will be the source of bugs in your code. So we've got global scope. We have local scope. We know that global variables with the same name, local variables with the same name as global variables have priority. Else about scope that we want to be aware of. Same thing with parameter names. So like if I have a global variable whose name is name, so var name equals me or whatever, when I call this function, it's going to use this name. It's going to use whatever value that name has, not the global name, right? But same thing. That's basically the same thing like we had declared an inside variable. So in old versions of JavaScript, and in fact, it may still be the case in the browser. So let's say I had a global variable named output, and then I had a local variable with output equals yikes, right? In previous versions of JavaScript, so what will this do? Sorry, excuse me. What is this going to do? Okay, and do what else?
Turn undefined.
Yes, and do what else?
Change the output or the value of the output.
This, I am not declaring a local variable here. I am using a global one. I only declare a variable when I use the var statement, right? Only then am I declaring a variable. When I do this, I'm actually assigning yikes to whatever variable already goes by the name output. I'm not making a new one. So you want to be aware of that. We will have, I think there are JS code checkers that keep an eye out for little mistakes like this because this can introduce a potentially serious bug into your program. You want to be sure that if you're using a local variable, you always precede it by var. And I bring that up because if any of you guys are old JavaScript hackers, you'll know that that was not a requirement previously in JavaScript and is still not necessarily one outside of Node, so in the browser. I can declare a variable like that in old versions of JavaScript. Very bad way to do it. Always put var in front of it so that you can avoid bugs like that. Even moreover, don't use global variables ever. So if you're coming from another programming language, just don't use them. And you'll have learned that with experience, when you create global variables, you are introducing the potential for nasty bugs into your code that are really hard to track down. Now, sometimes you're going to have to use a global variable. Keep it to a minimum. Make sure you have a very good reason why you're using that global variable. If you're using it because you have a whole bunch of functions that are trying to do something and you need to keep track of where you are in that process, and so you're like, well, I'll just stick a global variable on there and keep track of it in there, there's probably something wrong with the design of your program. Yeah, you probably need to design your program better. And that could mean passing around data between those functions that updates the information as it goes on that data rather than trying to track it with a global variable.
What constitutes a very good reason?
I've seen in like when you're using Backbone for front-end web development. Backbone is a framework, and you have to declare objects, so object definitions, almost like classes, reusable object things that you want to make available to all parts of your program, so you can like create new instances of them. You need to make those available from everywhere. You need a global variable for it, and so you'll commonly see a declaration like var app equals an empty object. And then everywhere inside of your application where it defines something that needs to be available all over the place, instead of just making a new variable for like my view or my model or whatever and assigning something to it, so now we're polluting our global namespace with tons of variables, it'll add it to app by saying app dot. And we haven't learned about JavaScript objects yet, that we're doing that today, but that's what's going on here. So, and then this way you only have one global variable called app and everything else goes on that. So. Does that make sense?
So it's like, that's kind of like your business object?
It'd be like,
Something that you can use that will pull that information like you.
yeah. You wouldn't want to use it for, so the difference is like you don't want to use it for tracking the status of what your application is doing. You want to use it to make reusable blocks of code available to the rest of your application without throwing a bunch of stuff inside of the global namespace. And this, I think this is way out of context, so it doesn't make sense, but this is the best reason that I can think of if you're familiar with front-end web development. It turns out that Node does a pretty good job of enforcing no global variables. There aren't actually any global variables really in Node. Variables will always be local to the script file. And when we learn about using Node specifically, we'll learn how to like link up multiple files together so we can have some of our code in some files and some of our code in other files. Variables defined in one file, under no circumstances, unless they're explicitly exported, are they available in some other file. So even if I put it in the global namespace in file A, it will not be available in file B. So Node kind of enforces that, so, which is probably smart, but can make sharing variables between files a little annoying. Yeah.
Would it be possible to share variables between files through inheritance?
JavaScript's object-oriented system is strange, to say the least. Do you know more about how prototyping works than not? Do you understand prototyping? Yeah, kind of. I might have you come up and, even though you said I don't want to do talk, we're going to cover prototyping a little bit. I think it's the strangest way to do any kind of object-oriented design, but we're going to talk about it some and maybe be able to answer the question then. So, but that won't come until a couple of days. So, all right. So at this point, let me review what we've covered so far. We have learned about functions. So that is what we try to wrap up here. Functions are ways of naming reusable blocks of code. Functions can have parameters, which are like local variables that we can assign values to when we call the function. So we can call the same bits of code, but give it a slightly different value each time. That way, if we have this really complex computation whose result depends on some variable X or some person's name or whatever, we don't have to rewrite that code everywhere using that value. We can just create a function and make it so that the variable parts use parameters like name or X or Y or something like that. The trick with functions, we can return values from them. If we don't, they're undefined, but if otherwise, the function will evaluate to something. And we need to be aware of scope. So there's global scope, and then functions have local scope. And the only time that we have a change in scope in JavaScript is when we enter into a function. Sort of the summation of 15 pages of introduction to functions. Yes? Brent, was there? No. I want to introduce another way of defining functions here that you guys have been encountering in Code Academy. That we mentioned this before, and Maiwo correctly pointed out the word for it, which is hoisting. This is really the big difference between declaring functions this way. But you'll see functions declared like this as well. So var, say goodbye to equals function, and then otherwise everything is the same, right? So console.log, something in there. Two ways to define functions. So either I can begin the statement with the function keyword, provide the name of the function, parameter list, and then the statements inside curly braces, or I can begin the statement as a variable declaration, define or use the identifier for that variable that I want, and then assign a function to it. And remember, because functions are values in JavaScript, functions are data, so we can assign them to variables. That's totally okay.
So the variable say goodbye to the global word not with the equals function.
That's right. So it'll still be a global variable. We can treat it as a function available anywhere in the program, but it does not get hoisted during that first pass. So remember, we talked about how JavaScript will take 2 passes through your file. On the first pass, it looks for all function definitions and makes them available globally, so that I can call functions that I haven't defined yet, so to speak. When I do this, say goodbye to is now ignored on that first pass and only available to code that happens below it. Otherwise, it will be a reference error.
Is that the purpose of doing that? Is so that it can only be used after that, or is there an advantage to doing that over just naming the function?
I'm not sure. Maiwo, do you know? Is there is there a reason why you would prefer declaring a function this way over this way?
Just the hoisting thing. If you don't want
Yeah.
hoisting, I guess.
Then you'd use the other way. Yeah. So that's like what you're saying. But we want to. The trick here, though, is remember that a function is data. So whatever say hello to is just an identifier that points to all this. So we could also do something like var same function equals say hello to, right? Sorry, not call it. So here I'm actually pointing this to this guy. So it'll be pointed to the same code. We can do that because functions are values. Functions are data. Remember, when we want to call this, anytime we want to call the function, we have to do it like that. Yeah, that's the big difference. So be aware of doing something like this and doing something like this. Both of those are valid statements in JavaScript. One of them calls the function and assigns this to whatever the function returns, which is here undefined. The other one assigns this variable to this function, right? So now we can call it like it is a function. Be careful. Okay, enough about functions. It's a big topic. Keep practicing at it with Code Academy. We'll look at our homework, I promise, at some point. But in the meantime, I'm going to continue on to discussing objects. So we're going to go to the next topic here. I'm going to make sure I'm in my Node REPL. So I'm just going to fire up Node. If you want to follow along, fire up Node. So an object is a way of grouping related variables. So if a function is like a way of grouping code statements so that we can like do computations over and over, an object is a way of grouping lots of variables, lots of values. And so an example of an object would be like a person, because a person has many values, like their first name, their last name, their age, their height, their sex, their hair color, and so on. I could declare a whole bunch of variables inside of my wherever I am. So like var name, var last name, var hair color, var age, var height, so on. But I want to move all of these things around at the same time. So like if I want to call a function that can do something with information about a person, it sure sucks to have a function that takes 6 parameters. It'd be nice to have a function that took 1, but that somehow had reference to all of these things, right? That's what an object does. In other languages, objects are called hashes or dictionaries. So if you've used hashes or dictionaries, it's the same thing. And they're called something else in R. Lists, maybe? I always think they're weird in R, but R is weird anyway. So an object lets us store these related pieces of value, or these related values together, and then we can treat this object like any other variable and use it. So we can pass it into functions, we can return it from functions, we can modify it, and so on. So objects are another fundamental concept in almost all of programming, but particularly in JavaScript. And when we talk about object-oriented programming, it will be in the context of objects. We'll get there. There are 2 ways to create an object in JavaScript. So one way is to use the new keyword. So I can say new and then capital object. And that makes a new object. And we can see that we get these curly braces back. That's what an empty new object looks like. Empty curly braces. Also, I can just use those 2 curly braces to create a new object. Functionally equivalent. So this accomplishes the same thing. And again, when we evaluate this, it's being evaluated to whatever the hell that means, right? We're going to find out what that means. In this class, we're going to emphasize creating new objects using curly braces rather than the new keyword. And the new keyword will be reserved for some other things. So the point of an object, though, is to collect bits of information, right? So I could create an object that is just 2 empty curly braces, or I could put something in there. And the way we do that is by specifying a name, or what's known as a key or a property. And those are technical terms. And so here I'm going to use the word city for a key. And notice I don't put this in quotes or anything. I just say city. And then I give it a colon, and then give it the variable that I want to be associated with that name, or with that property. And so I'll say, in quotes, Oklahoma City.
Singular or double quotes?
Either way. Same thing in JavaScript. And then I close it. And so now this guy evaluates to an object with 1 key, city, whose value is Oklahoma City. So you can think of this object has something somehow associated with it called city, and it points to a string that is whose value is Oklahoma City, right? We call this a key pair, the key and the object, or and the value, excuse me. But another way of referring to this guy is as a property. So I'm going to use that interchangeably. Don't get confused. I can create an object with many key value pairs or with many properties. So I can say city colon Oklahoma City, and then I use a comma to separate them. So after the first pair, I give it a comma, and then I could say population, and I can make it a number this time, so I'll say 600,000, comma, and then I can say state, and in a string, I'll say OK with capital letters. That'll be the last one, and then I'll close the curly braces. And so now I've got an object that is holding 3 pieces of data that I can reference by name. Yeah, and we'll see how to do that in a second. But basically, this is like one whole unit now that has a city, population, and state. And again, the syntax for that, I open up a curly braces, and then I give it a key identifier, so I'll say key, and then colon, and then the value that I want it to have. And if I want to have more than one, I use a comma. So key 2, val 2, comma, and however many others I want, and then I close it with a closing curly braces. And now that is one structural whole. Now I'm just declaring these like I'm declaring the variable for the value 42. And so in Node in the REPL, that just evaluates to itself, and then I lose it. I can't use it anymore. An object is just a value. It's a collection. It is a value that is a collection of values. So I can assign it to a variable. So I could say var OKC equals, and now let's stick that stuff in there. So I'm going to open my parentheses, and I go to a new line for readability. And notice that Node automatically tabs it over. I say city colon Oklahoma City, comma. I say population, and mind your quotes, 600,000 as a number, comma. And then I say state, OK in quotes, new line, close my curly braces. The result of declaring a variable is undefined, but now I have OKC inside of my environment. Let me jump to the top of the screen here. That is that object. Yeah. So I've got a new variable. The variable's name is OKC. It points to an object. I could have said var empty object equals an empty object, like that. And now empty object is just this empty thing. Either way, just normal variable declaration, but now I'm doing it with these object things, right? What does this kind of look like?
CSS.
CSS really is what I was going for, yeah? And so in CSS, we call those properties, right? I mean, when I do CSS, I also do an open curly braces, property name, like text align or whatever, color, colon, and then its value. And then I don't think I have, do I have to put commas in CSS? I don't think so, right? I don't remember. And then I just give it another property name, prop2, value 2, and so on.
Do you have to keep the properties in the same order? Or as long as they're stated there, it'll sort them out?
No, good question. So you can define your properties in any order, right? Doesn't matter what order you define them in. So I said city, population, state. I could have said population, state, city. Doesn't matter. Order is indifferent inside of an object. What matters is the name. That's the only thing that really matters.
Is it case sensitive?
It is case sensitive. Oh, absolutely. So. Let's create a couple more of these just for practice, just so you can see what I'm doing here. So I could say var Chicago equals, I'm declaring a variable, open up my curly braces. I could say city colon in quotes Chicago, state, so declaring it in a different order this time, IL, and then population. Anybody know what the population of Chicago is without looking at my notes?
1.2 million?
Much larger. Almost 3 million, so 2.7 million. Had no idea. And so now Chicago,
That's probably city proper too.
that's just the proper, that's right, so not including suburbs and stuff, is that. And it looks like what's happening here is when Node prints that out, it's organizing the keys by their case, by their their first letter. So it's just sorting it by name. Okay. Great. I have an object. I have OKC. I have Chicago. Now I want to do stuff with these objects. I've got the variables. I could pass them around, but really the first thing I want to be able to do is get access to these values. I want to get the name of OKC, or I want to get the population of OKC. How do I do that? Something called dot notation. And so I will give it the name of the variable, which is, say, OKC, and then a dot for dot notation, and now I can provide it with any of the properties that are associated with OKC. So I could say OKC.city is Oklahoma City. OKC.population, and I can use tab complete to get that, is 600,000. OKC.state is Oklahoma, and likewise for Chicago. So I could say Chicago.state is Illinois. This is called, yes, nope. Oh, this is called dot notation. When JavaScript sees this, first it looks at the variable on the left, tries to find out if that's an object, or assumes it's an object because you now have a dot there. So it finds that this variable inside of your scope, sees that dot, which means, okay, treat this thing like an object. Now whatever comes to the right of that dot, find that property on that object and resolve this whole statement, evaluate this whole, I guess, expression really, to whatever value that property has on the object, right? It's not too bad, right? It's collections of data. Looks a little bit like CSS. Any questions about that? Nobody too confused?
We'll give. Go ahead.
You can't edit them if they're in Node, like if you mistype something.
No, if you mistype something, so you'll see that it just keeps on waiting for input, right? Control C to get out of that. So that's okay. So I do that all the time when I'm preparing this stuff as well. Yeah. You'll get a syntax error if you have it in a file and try to run it, but yes.
I just want to ask, I'm sure we'll get to the point where you can ask a question, what is the population, as opposed to the dot Chicago, yes.
How do you mean?
In other words, what is the capital of, what is the population of Chicago?
Mm-hmm.
So you could put it in the console, say, put your question, plus, and then the OKC dot city, if you or population, right?
I guess I'm not sure what you're asking.
That's useful for programming, but in terms of the end user.
Oh, okay, so you're right. You'd write. Okay, so all right, good. So what'll happen is yes. So what we're sort of hinting at here is how we're going to model data. So we're going to have like data that we want to keep track of, like a blog post is what we're going to end up doing with a title and some comments or whatever. And then in our interface, there will be a way to select different posts. But that's interface, and then our selection will get communicated back to the server. The server will pull out the right model and pass that back to the interface, which will make sure everything appears correctly. So yeah, right. So I mean, we couldn't in our code we couldn't ask what is the population of Chicago, but we will set it up so that our program altogether has that kind of interface. So yeah. I mean, you're in a sense what you're saying, like you could almost run a Node program that lets you type what is the population of Chicago at the console or as part of the program, and then you could parse that input, pull out the city that they're asking, and then dynamically figure out which one of your variables corresponds to that city, and then go grab its population and print it out to the screen. So you could do that as well. We're not set up to be able to do that just yet. So. Okay, so what happens if I try to access a property that does not exist on this object?
Get a reference there.
Hardly. Are you guys? How are you? Are you guys doing something that gives you that? So let's do OKC.colors. Undefined. That should frustrate you a little bit. Really, you might think I want a reference error, but properties are not variables. They're not identifiers. Yeah, they're names for things on an object. That's all they are. So when I say OKC.colors, Node or the JavaScript runtime pulls my OKC error variable out of the environment or out of the scope, and goes and tries to find colors on it, but I haven't defined colors on it, so colors is just an undefined property. Yeah.
But you can go back and just add colors to that if you wanted to.
Yes, I can. Yep, we'll see how to.
You don't have to put everything back in.
No, that's right. So we're going to see how to do that in just a second. What is important here is that in other programming languages, this causes your program to crash. You just tried to access information that is not defined, and your program will freak out and it crash, right? In JavaScript, JavaScript goes, kind of shrugs its shoulders and lets you keep going. Some people really like that. Some people really hate that. If you have a bug in your program, so if you defined OKC.colors to be something, so we defined it up here, and then I spelled it like that, or my British friend spelled it like that in the code with a U in there, this is just going to return undefined, and the program is going to keep running. And you might really need the correct value for your program to do what it's supposed to do, but instead, it's just going to be undefined, and your program is going to work with that, which is a bug. So we want to be aware of that. And so usually if you're in a strongly typed language, your program may not even compile. In other cases, you'll get a runtime error and it will crash on you. In JavaScript's case, we do extensive testing inside of our function, so we'll run an if statement to make sure that the value we get is not undefined. If it is, then we can raise an error. So basically, JavaScript is giving us the power to do what we want to do with this sort of undefined availability. What was the other? We write tests. So we actually write code that runs our code to make sure that our code is doing what we think it should be doing. Unfortunately, that's a little more advanced, so we probably won't get into it in this class, but test-driven development is a common practice in modern software engineering, where you actually write your tests first and then write your code so that it passes those tests. So,
is there an app or something that helps us with that?
Yeah, you use a framework. So some of the ones that are popular in JavaScript are like Jasmine is one, JUnit is another. And in Ruby, people use RSpec, which is very common. And so it lets you write out little tests that execute your code as you go. So, but we won't get into that. So, for now, I want you to be aware that this is a common mistake and will bite you in the butt at some point. I'm going to cover one more topic about accessing variables, and then we'll take a break. So, I'm using dot notation, right? So I can say Chicago.population dot specifically population for dot notation, or I can say OKC.state and so on. Objects give us another way to access the properties, and it's called bracket notation. And so in addition to OKC dot, I could say OKC and then provide square brackets. And inside those square brackets, I give it a string, so I have to put it in quotes, of the name of the property that I want. So like state. These are functionally equivalent. Yeah. There may be some under the hood stuff that's a little bit different that I don't know about, but they accomplish the exact same thing. The one does not need quotes. Dot notation does not require quotes. The other does. Yeah. Maybe the advantage of doing it this way, there's one that's obvious, but there's one that is maybe a little less obvious. What if I want to look up the property on an object, but I don't know which property I want to look up yet, like when I'm writing my program? I want my user to let them choose which property. So we give them an input field that says, tell me what you want to know about Chicago. And the user says, well, I want to know about its population. So we have some variable that will choose the property, or let's say chosen property, gets assigned to whatever they've decided. So it'll get assigned through the input to population as a string. Now I can refer to OKC's chosen property like that. Because chosen property is, remember, just a string that is population, and population, when used with bracket notation, will get resolved to a property on my object OKC, so that gets all resolved to 600,000. Right? So that's maybe one of the advantages of doing it with the bracket notation. There might be preferences that some programmers have for using one or the other. Dot notation is more efficient, certainly. In some cases, you cannot use dot notation. So just as there are rules for the kinds of characters, that is like letters and numbers and other symbols that we can use for our variable names in JavaScript, there are also rules about what kinds of characters we can use for our property names. A property name, so I'm going to define a new object here, cannot have dashes in it. So when I do this, notice it's not letting me quit. So the REPL is freaking out and going, hey, I don't know what you mean. I can't figure out what your syntax is. I'm still waiting for something. It's broken. Yeah. If we do this in our program and try to run the program, we'll get a syntax error. So I have to Control-C. We cannot put dashes inside of our property names. Sometimes, though, you're going to end up with objects that have dashes in them beyond your control because they're coming from a server in the form of what's known as JSON, which is the JavaScript object notation. It's a way of saving these objects as text, sending them around, and then turning them back into objects on some other computer. And sometimes people put dashes in their property names. So how do we access those when they have dashes on them? First, let's go ahead and define them with dashes. So how would I do this with has dashes? I can use quotes. Inside my object definition, so let me put that up at the top here, I can say, oops, that's too many. Yeah, no, we got a bug somewhere. Let's make sure that it's not, there we go.
It's inception.
It's inception. I'm going to restart node. Okay, that was crazy. So I can say has dashes in quotes, and now this whole thing, including the dash, becomes the first key on this object. I can do that. That's okay. A little unusual, but now I can say colon and then some value, right? Close it, and now that works. Now I actually have an object whose first key or whose first property is this has dashes in it with a dash. So how am I going to access that? I cannot do it like this. So let me assign that to a variable. So var example equals all that stuff. So we know that that's what my example is. Great. If I try to say example dot has dashes, I get this. Dashes is not defined, a reference error. So it's like looking at has, trying to find example dot has, and then trying to subtract dashes from it. I think that's what it's doing, right? That's how this syntax gets evaluated. Obviously not what we want. Instead, I have to use bracket notation. And bracket notation doesn't care because it's a string, and I can put whatever I want inside of a string, right? So I want you to be aware of that. Dot notation is probably what you're going to use 98% of the time. Bracket notation will sometimes be necessary. Let's take a break. 5 minutes. Hey.
So I was actually trying to get here earlier. This is Adam. He just started working at MCM.
Hey, how's it going, man?
It's been pretty good. He's like super dope. So speaking of things that prototypical inheritance thing, he's actually done videos on like CoffeeScript, Erlang, and whatnot.
Oh, cool.
So,
if you want to if you want to talk about JavaScript's weird inheritance system.
yeah. He's a really good dev, and he's good with JavaScript. So I was thinking like one of the classes that you wanted to do, like the prototypical one.
Yeah.
You know, you could do it. You know what I mean?
Cool. We might do that. Would you be interested in doing that?
Yeah, definitely.
Typing out JavaScript's just prototype system. So I want to do a lesson on object-oriented programming. I want to do one on the functional aspects, which I can handle. But then I also want to do one on its object-oriented, and at least make them aware of the fact that it's a prototype-based. Although it won't get used so often in Node, they should know because they'll encounter it in other places. But sorry, go ahead.
You know, the prototype chain is crazy. Like.
Yeah, I know, right? and so I mean, it still confuses me.
Yeah, the fact that underscore proto underscore underscore is different from like dot prototype on an object just throws me off every time.
Yeah, it's pretty.
Yeah.
Some mild stuff is out there.
So be aware that this is a really basic class. So it won't we don't want to get into anything too advanced. Mostly we want it to be like we create new sort of objects using this new keyword. We can define functions on those and refer to this, and that's great. But unless we're using prototypes, all of that stuff gets copied around. So we use prototypes to prevent that from happening. And how does that change how things work a little bit? Anything more advanced is probably going to be too much for the class. Yeah.
So what about the, so are you going to go over like, the this stuff and the function apply stuff?
So I'll probably go over this stuff in terms of just like basic objects. Like, you can have a function on an object and you can refer to its properties. And then I could leave everything else to you. So like scope. So would that be like this stuff? Like scope, would that be considered part of the like inheritance and stuff? Because you are kind of like when it's referring to yourself. Yeah. Yeah, that could all go in there. And you could talk about how apply and things. Although that, I mean, I think that's worth mentioning because it's cool, but it'll probably confuse half of them.
Yeah.
Like changing what your scope is when you call. Yeah.
Because it's kind of like how it hinges. It's like ordinarily it's just like this, and then you find the prototype to the, it's
Yeah,
kind of
but I mean, like call and apply could have been covered in functions. Those are actually methods
on functions. Yeah, right. Yeah, which we haven't even covered as like, oh, by the way, functions are also objects, and you can define other things on them. Like here, let me put a variable on this function. So that would probably be, I mean, that could be on, are you going to be here Monday and Wednesday, or?
Yeah, definitely.
So that, I mean, I don't know how much time you want to prepare for the lesson, so I always end up like making a thing that usually ends up being about 10 pages for one of the topics, and that goes on our GitHub repo. Whether you want to do that or not is up to you. What I cover for that class, I'll do that for, but it would either be on Wednesday or Monday. We could set it up to be on Monday. That way you got some time to think about it and prepare anything you want.
Nice. Do you have any like? You probably have some stuff prepared, maybe.
I don't have the things prepared yet that I'll be doing on Monday. I'm still trying to get ahead on the class. It's definitely going to happen once we start the note stuff. But anything I work on in terms of what I'll talk about when it comes to objects, I can send you. So do you want to just shoot his email my way, or make sure I get your email address?
Yeah, sure.
Plan on Monday?
Yeah, Monday.
Cool.
I didn't know it'd be so soon, but whatever.
That's all right. I do some. There's a lot of material there.
All right.
So make sure you don't make it like leather pants. Yeah.
Basics, yeah, definitely basics. We want them to know how it works, but definitely basics. Cool. Well, that's great because I'm like I could try to teach it and I still don't get it very well. So.
Yeah, it's
difficult.
It's difficult. Yeah. It's unique. It's like nobody does it any other that way, and like IO is the only other language I've been introduced that does it that way.
I don't even know what that is.
Yeah, right.
that's cool.
Sweet. Thanks, man.
Thanks, Adam. I got to go home. I was trying to get to class early so he could like meet you before class started, but like we just couldn't do it.
That's all right. Cool.
Who's looking for
I'm sorry, but yeah, they'll give you your money back.
Yeah, I sent a letter today.
you get structured databases, you get service, you get master.
Okay.
I actually texted him with them.
Oh, yeah?
Actually, that's what I found. People don't do it. I can do it, and we like coordinate.
Really cool.
And he failed. He failed. He did that.
All right, let's get started again, guys. Back to our seats, back to our seats. All right. So we've declared some objects. We got OKC. Apparently we don't because I restarted the REPL. So let me make a new OKC. So I say var OKC equals. I had, what was it, name, city, something like that? So name, city. City was Oklahoma City. Population was 600,000. And the state was okay. And I've got my object. I can access it with dot notation and bracket notation to access the values. What if I want to modify this object? So I want to change this object, as Todd was mentioning. So let's say I want to change the population. A new baby just got born. Was not my baby, thank God. But we have a new baby. We want to update the population to see. Babies are terrifying. Seriously. So I want to update it. I can use the assignment operator just like I normally do with a variable. So if I had some variable that was pop and I wanted to set pop to a new value, like 56, assignment operation, right? Single equals sign. I can do the exact same thing with my object. So I can say city dot population. I'm sorry, OKC dot population. I was wondering why that didn't tab complete. And the assignment operator. So equals, and then whatever I want the new value to be. So I could say 600,001, right? And now I have permanently updated the population property on this object. So if I say OKC.population, it is now 600,001, right? I've changed that value permanently. That's its value now. Similarly, I can do these with other parts of the object. So I could say OKC.city equals, OKC.state equals, but it's not often that you move cities, so I won't. And then, I could do this with a bracket notation as well, right? Oop. I can recover from this because it ignores white space. So if that looks really strange, we'll say another baby got born, or another 102,000 babies. There we go. And oh, I thought I could recover from it. Guess not. Okay, see bracket. Population equals 600,002. Bingo, right? Either way. Dot notation or bracket notation is totally okay. So I can modify properties that the object already has. I can add new properties to the object as well. So we see that OKC does not, let's say, doesn't have a basketball team right now. So I'll say basketball. Undefined. That's what happens if I try to access a property that doesn't exist. But if I want to set a new property, again, I use whatever property name I want the new property to be, and I use the assignment operator and assign it to some value, like Thunder. I just created a new property on that object. Boom. JavaScript does all the work for me. So OKC.basketball is now permanently equal to Thunder. So I can add properties. I can modify properties, I can add properties, and I can delete properties. So if I want to completely get rid of one of these values, so I look at OKC and it's got 4 values now. And I want to say, okay, you know what? The Thunder decided to go back to Seattle, so I'm going to delete basketball. So I delete is a keyword in JavaScript. It's not a function, it's a keyword, it's an operation. And I could delete OKC.basketball. I don't know why it returns true. It succeeded, I guess. I don't know. Haven't been able to figure that out. And now OKC no longer has a basketball property, right? If I try to access it again, it's undefined. Why would you want to delete things? To free up the memory that they occupy inside of a running program. Although in practical terms, you very rarely see that in JavaScript. So this means that objects are mutable. That's the technical term for this. We can change objects. In other programming languages, once you create an object or some kind of data structure, you cannot change it. You can make copies of it, or you can add things to it that return a copy of it with that thing added to it, but you cannot change the thing itself. JavaScript lets you mutate. This is scary. Okay, why is this scary? Mutation is probably the source of like 90% of programmers' bugs next to global objects or global variables. Let's say I have this function modify. So I'm doing this in the REPL so I can show you this stuff live. Function modify, and it takes an object. And it updates, for whatever reason, the city on that object to new city. right? And then the function is done. That's all the function does. So I can tell by what I'm doing with this parameter, object, that it must actually be an object, and it probably has a property city, maybe. And so I've got OKC here. What happens if I call modify with OKC? So I do that. And in our previous lesson, we had learned that object is local to this function, yeah? So really, you would think whatever I'm doing to object is only applicable inside of that function, yeah? If I pass a normal variable to it, like name, and I set name to something inside of this function, name is still going to be what it used to be. Not so with objects. So now OKC, the city on OKC is now called new city. This happens because objects are passed by reference in JavaScript. Again, that's another technical term that you don't want to worry about too much. But rather than, unlike every other example we've seen so far, rather than evaluating the object OKC into its underlying piece of data and passing that piece of data while leaving this reference alone, this identifier alone, this time it actually passes the reference itself, right? Rather than the underlying bit of data. When you pass the underlying bit of data, that's called pass by value in a programming language. When you pass the reference, it's called pass by reference. Under the hood, it's actually passing a memory address where this data is stored. And then this function actually accesses data at that memory address, and OKC still points to that. So we've actually changed the data. This is a massive source of bugs in programming languages, particularly in JavaScript. Be aware that you can do this. Be aware that objects are passed by reference and that they are mutable. Because you'll write a function that accidentally changes the object out from underneath you without realizing that that's what the function does. Good programmers don't write functions that do that. Don't do that, right? Be aware that it can happen. The reason for this, my understanding, is that objects can get huge. You could have an object that contains objects, that contains other objects, that contains an array of objects 1,000,000 times over. And if you want to try to pass that to a function, and it has to copy all of those values before it passes it to the function, which is what it would be if it weren't passing it by reference like this, then you got to take a huge chunk of memory, make a copy of it, which runs it through the processor, and then actually sends that off into that function, which is another bit of code running in memory, and that takes time. So it slows down the computation. And so I believe it was for efficiency reason that they did this. Mostly I just want you to be aware of it and that it is a source of problems. Mutability, ladies and gentlemen. Objects can be nested. So an object is a variable. So OKC, is a bit of data, is a piece of data. An object is a value. This thing is a value. We know that objects are composed of key value pairs, so I could set this value on another object, right? Now I am nesting objects. And so that looks like, let's see what the syntax for that looks like. I'm going to redefine OKC. So I'll say var OKC equals. I'm opening up my object. Let me move this to the top and do it one more time. So var OKC equals. Again, there's a city. It's Oklahoma City. Again, it's a state with OK. Again, it's a population, 600,000. But now, let's define basketball with a little bit more information. So instead of it being a string, I want it to be another object. So I'm going to start up another curly braces. Node indents me one more time to let me know that I'm doing that, and I'll say league, and now it's just another object. I'm going to treat it like another object. So NBA, comma, team, Thunder, comma, stadium, Chesapeake Arena, if I spelled that correctly. Then I need to close this object, which is associated with basketball, and then I need to close the whole object that's associated with OKC. I have just nested an object inside my object. Totally okay. OKC. In my
have a single quote and a double quote to Chesapeake Arena. That was the worst one.
Yep, good catch. We can nest objects as deeply as we want, and we can nest as many objects at whatever level that we want on another object. Why can we do this? Because an object itself is just a value, and an object is composed of key value pairs. So it gets this recursive sort of self-referential structure. Objects composed of other objects. Just like a programming language is statements composed of other statements, right?
Is there any kind of scope within an object whenever you're creating it like that?
There is.
I guess functions were the only thing that has scope outside of global.
We'll learn that objects do have scope by use of a keyword this that allows you to refer to the properties on that object from inside that object. So we will learn about that in a coming lesson. So yes, but we're not there yet. So right now we're just treating objects as ways to carry around bits of data, right? So how do I access this nested information in here? So let me clear that again and put it up at the top. So I know I can get okc.city. So if I want basketball, I should be able to say okc.basketball. And that resolves to that. So now what do I do if I want to get the team name inside of basketball? Yeah, another dot, right? okc.basketball resolves to an object, and we know that we can access properties on that object with dot. So I can chain these dots. It's called chaining. okc.basketball.team is the Thunder. And I could use bracket notation for this as well. So objects, again to reiterate, are key value pairs. As we've learned, a function in JavaScript is also a value. Functions are values. That means that we can associate functions with our objects by name. So I could say var, sorry, got lost on my notes, jumped ahead of myself. Var, say welcome, equals some kind of object, yeah? And actually, I'll Control C again and start up at the top. So say welcome equals. And I'll have a key in German. But in German is going to be a function instead of a variable, or instead of a value, excuse me. And this function will simply do console.log willkommen. And then I close the function. And now I want to go to the next key on my object, so I need a comma. I could have put it up there. And I'll say in English. In English is also a function that logs, hello, actually it logs welcome. And then I close that function, and then I need a comma for my next key. And then I had one for French as well, but I'll just close it. And so now say welcome is an object with two properties in German and in English whose values are functions. I am now carrying around functions with this object. Yeah. How do I access these functions? Same way I access any other property, dot notation. So I can say welcome dot in English. But it's a function. So if I want to use it, I need to call it, right? So I really want to say welcome dot in English with parentheses. And now it calls the function on that object. Starting to get into object-oriented programming, we're going to learn way more about this in a future lesson. But the point being here is that I can stick functions on objects, and now those functions get carried around with that object.
Why do you get the second undefined?
Because the result of evaluating the function is undefined. Right. So, but that's a good question. I think that is a little bit confusing. Welcome is what we print to the console, or welcome in New English. And undefined is the result of evaluating the function, and Node always prints the result of the evaluation. So, pretty wild, right? I could do this in bracket notation, which looks a little bit weirder. Say welcome dot, bracket quotes in German, also that function. And now if I want to call it, I give it parentheses. That looks bizarre. But it does exactly what I want it to. And is no different from anything that we've been doing already. I'm just using bracket notation, and I'm calling the function that it returns, right? Or that it evaluates to, excuse me. This is a very common idiom in JavaScript. So typically what we'll do is we'll declare an object that has a couple of callback functions on it. And I'm going to show you this inside of Sublime. So I'll have a var callbacks equals some kind of object with a success property, that is a function, and a comma, failure property, that is also a function. And these guys will do something. Yeah. Now I'm going to have an actual function that performs some long computation. And this long computation is going to take a parameter. We'll have a parameter that, and I guess to clarify, although it doesn't matter, that is callbacks. Right? I could have called this callbacks as well, and we know that that's okay because I'm in different scopes, right? But to avoid confusion. And so this long computation is going to do something that takes a long time. It's going to be asynchronous, as we'll learn about in Node, which means my code will continue executing while it's doing that in the background, although not on a separate thread. It's a little bit different. And if this whole thing is successful, so actually let's say explicitly var successful equals true. If this whole thing was successful, I'm going to call success on whatever object gets passed into this function. So like I'm carrying around functions, passing them to the object, I'm passing them to the function, and then this function is going to call those functions on that object depending on the result of the operation. And I say, otherwise, call failure. Now, how do I actually use this? I need to call this function, long computation, with this object, my callbacks. Of course, I have to do it after I've defined them, so let me move it down. This is in the notes. I'm not going to belabor this. Look over this in the notes and make sure you understand what is going on here. This is essential. We have practice on this in the homework assignment, but basically define an object, define two properties on the object. They're both functions. I can call those functions. So I have some other normal function somewhere else that is long computation. I call that function with this object, and then inside of this guy, depending on the result of the operation, on that object, which is this, I will either call success or I will call failure. This is a way for me to pass or to collect functions into one whole unit and pass them around, right? And we are going to see this everywhere in Node. So we want to make sure that we understand this clearly. Think about it. Make sure you look over it in the assignments. Try it and see if you can understand the control flow, like how the program is moving around inside of your code. Add a bunch of console.logs inside of each of these to see which ones get called first, right? Last thing with objects. Everything that we have been working with so far, even though we haven't really realized it, is actually an object. An object of a particular kind, a functional object, I suppose, or however this is properly called in JavaScript. And they all have properties. And some of them have methods. Or rather, they all have methods and some of them have properties. So let's say I've got a string, var, my name, I'll just say name, equals, and I'm back in my REPL, Philip. We know this is a string. Turns out that strings are also objects and have properties, like length. The length of this string is 6. That's the number of letters in it. They have functions as well. So just as we've seen that we can define functions on our objects, a string also has a toUpperCase function that turns the string into uppercase letters. And so now I've got a piece of data that's carrying around some information and also has operations associated with it or functions associated with it that can change the data that they are associated with. I could have some other string like var other name equals James, that's my brother's name. And now if I call a function on James, so other name, applies only to that bit of data, right? We're going to learn more about how this works when we talk about object-oriented programming, but really the trick to be aware of right now is that every single type of data that we've been using so far is also actually an object underneath the hood. Yeah?
So quick question. When you were talking about how things are mutable, that sort of thing. Now, every time you call name from there on out, or other name from there on out, will it be uppercase, or will
Good. That's a great question. So, and the answer is no in this case. This is a function that is returning a value, but not actually modifying name itself. And that is almost certainly a good thing. So, in other programming languages, if you've worked with Ruby before, oftentimes Ruby will provide two functions. One that is toUpperCase, and then the other that is toUpperCase with an exclamation mark. And the exclamation mark signifies that it actually changes the underlying data and doesn't just return a value. It's like a warning. Hey, I'm actually changing this. Because normally mutability is a dangerous thing, and we don't want it to change. We just want the result. So some of these have really great uses. So I'm going to give you one more before we go on to our next topic, and it works as an excellent segue. If I have a string, so let's say I have a var words equals hello world, this is a string with many words, right? So I just basically am declaring a string of text, and that's my word. There is a function on strings called split that will split this string wherever a certain character appears. And a common character to use is a space. And so I just put a space in quotes. And it's going to take every single place where a space occurs in this string, extract what's between those, and stick them inside of an array, which is what we are going to learn next. But the point here is really everything that we've been using, everything is a function, excuse me, is an object, and they have things on them. Including numbers, let me show you real quick. So there's a math.py, which is pi. I can assign that to say math.py. And you think, oh, that's a number. That's just a basic data type. If you've used other languages, that can't have functions on it. Surely not. But pi, all numbers, in fact, have a toPrecision function that lets me specify how many numbers in that I want to actually show, as in another example, right? There are no, what are they called in C and Java? Primitives. There are no primitives. Everything's an object in JavaScript, if you're familiar with other programming languages. Questions? It's a lot to take in. All of these notes are available. Homework covers this information. So
on the link that you did, you didn't put the parens.
No, because it's not a function. It's just a property, right?
Okay.
So, but you have to be careful. Let's see. What happens if I try to take a string like name and assign the length? Well, it says OK. It's clearly not length 10. And it ignores the value. So underneath the hood, something is going on here where it's like, yeah, you can assign to it, but you know what? I'm not actually going to let you assign to it. I'm going to ignore that. Yeah. Which is the right thing to do, but is weird, because this really should throw an error, right? You'd really think length can't be mutable. You can't change the length of a string. You have to change the string. JavaScript weirdness. Okay. We're going to get through as much of arrays as we can. We've actually got about 20 to 30 minutes, so it's not too bad. We're kind of catching up. We have objects, which are collections of data accessible by name. We have arrays, which are collections of data accessible by their position in a list. Yeah. So an array, rather than being a bunch of like things that we want to keep together and move around, like a name and an age and a sex and a height and whatever, an array is going to be a list of items. And typically it will be a list of similar items. And we access those items in the list by their position. We saw that position doesn't matter with objects. Position is everything with arrays. We cannot refer to items in an array by name. We have to refer to them by their location, their position, which is called their index. Okay. Oftentimes, arrays will be of similar things. So like we'll have an array of numbers or an array of strings or an array of objects. But an array can be of different types as well. We can stick whatever we want in an array. If we create an object with curly braces, we create an array with square brackets. So that's an array. Basically, that thing right there is an empty array. We can also use the new array syntax like that, just as we could with object, functionally equivalent. In this class, we will always prefer the brackets. It's called the array literal. We stick things in the array, well, simply by sticking them in there. So I take the number 5 and I put it inside of this array, and now I have an array with the value 5 in it. I want to put a string in it, so I say hello, and all of this spacing is optional. I'm just using it for clarity. Now I have an array with the string hello in it, right? An array can contain as many items as we want. So if I want to put the numbers 1, 2, 3, 4, 5 in the array, I separate them with commas. Similar to how we were separating key value pairs in objects, we use commas for the separation. And now I have an array with the numbers 1, 2, 3, 4, and 5 in it, right? And notice that the position is the exact same as it was when I created it. I could reverse that order. So I could say 5, 4, 3, 2, 1 if I'm not drunk. And in fact, that position stays. It does not automatically sort. Position is essential for an array. That is how we access its elements, as we're going to see in just a second. I could have an array of names, so I could, or of strings rather. So I've got a string, you know, Philip, if I can type, with a comma, Mark, comma, James, comma, Mary, comma, Margaret, and so on. And now I have an array of text. And Node prints it out like that for additional clarity. So it shows this list. And this is literally just a list of items. It's like a grocery list or a checklist, right? How do I get access to these things? Well, first I need to save them. So let's create a variable. Let's declare a variable that is an array of numbers. And I'm going to do something a little different here. I'm going to start at 0. So now numbers is a list or an array, 0 to 4. And I could say names, likewise, var names is equal to Philip, Mary, James. I'll do 3. So now names is this list, right? Or this array. Yeah.
If we did not include the quotes, that would be referencing variables that we have already declared, correct?
Yep. So it would be variable referencing. And since we haven't declared those variables, we get an error.
Okay. But we can do that so that way the user can create arrays.
Sure. So let's say I had var x equals 5, var y equals 10. Now I can make an array that uses the variables x and y. And they are evaluated to their values, and then those values are stuck inside of the array. So this array no longer has x and y in it. This array has 5 and 10 in it. Again, as we already saw with objects, just like objects are passed by reference to functions, they are also passed by reference in arrays. We actually have the object thing in there rather than its data. So if we change it, it'll get reflected in the array. We'll get into that later. What I mean is, let's say I update the variable x to be, I don't know, 400, blah, blah, whatever. This previous array that I declared, which I lost, unfortunately, wouldn't have changed. So var example equals, sorry, let me reset x equals to 5, right? So var example equals x comma y. Example is, whoa, 510, right? So just so we can see what's going on there. Now I'm going to update x to be some other value, but example remains the same. It's not getting x, it's getting the data, it's getting the value, right? Okay, so I've got names, and I've got numbers. Let's get access to these things. So when we use objects, we have dot notation, right? And we say object dot property name or object dot key. Or we could use bracket notation and put the thing in quotes. Arrays must use bracket notation. We can only access objects and arrays with brackets. And we use the index, what it's called, or the position of the item in the array as a number, right? So I could say, give me the first object, names 1, except that's not the first object. Mary is actually the second object. We index arrays in JavaScript starting at the number 0. The first item in an array is always at the 0th index. Which is
that way for the strings too.
As well, that's right. Yep, in the homework. So as we saw, we can almost treat a string like an array that has characters in it as its components, and we start at 0 when we say car at, right? Exact same thing with arrays. And that's why I put this number 0 here first, because if I want to do numbers at the 0th, then it gives me 0, right? We always start with 0. 0 is 1 and 1 is 2, in a sense. Just think of 0 as being where you start.
So with strings, do you usually 0 as well?
Yes. So if I had a string like, say, var name equals Philip, and I say name car at, so as a function on every string, I have to, and I want to get the first letter in the string, I have to begin with the 0th index as well.
No, I meant when you have an array
Mm-hmm.
and you're defining a bunch of, I guess, strings within that array. So
Like this guy here?
Yeah.
Yep. No, right. See, names 1 is actually the second item.
Okay.
Yep. So that's just how arrays work. It doesn't matter what's in the array. Arrays always begin at the 0th index. I actually think arrays are pretty easy. I don't think this is hard. This is probably some of the easiest complex syntax that we'll have learned so far. Objects are a little weirder, and functions are certainly take a little bit to wrap around. But basically, I just have a list of things, right? No big deal. If I try to access an item at an index that does not have a value, so I only have 3 names, what happens if I try to get the 10th one, which is actually the 11th index? What is going to happen here? JavaScript tells me undefined, which is probably not what we want. Again, in many programming languages, if you try to access a value beyond the memory storage allocated for that item, your program will likely do something very bad. So an out of bounds error, or it'll crash or something. In C, you could totally blow up data. So you get a seg fault, especially if you try to assign to it. JavaScript just goes, shrugs again. It's up to us to decide what we want to do there and not make the mistake in the first place. So modifying an array is very similar to modifying an object. Again, we use bracket notation, and again, we use the indices at the beginning with 0. So if I want to take names and I want to update the first item, I say names0, that's Philip. Names0 equals, so I use my assignment operator, say Philip Joseph Dow, that's my name. And now my array reflects that new value, right? So I just updated that value in my array. I modified it. What if I want to add a new item? So let's add a 4th item to this array. So if I do this, I say names. 2 is my last one, so really I want to give it at 3. So names3 equals someone new name. And now my array has that one added to it. It's very common to want to add a new item at the very end of an array. Easy way to do this is with the lengths property. So an array, just as you might suspect, is an object as well, has a property named length. I've got 4 of these. What's handy is that the 4th index is the next one that's usable. It's undefined at this point because we know that actually 3 is the last one. So if I want to add a new item to the end of my array, I could say names at names.length equals, here's one on the end. And it got appended to the end, right? Do you understand why that works?
Why did it have a slash?
Why does it have a slash? So quote is a special character in JavaScript that represents the beginning of a string. If we encounter another quote, that represents the end of the string. But we're not actually finished with the string, so we use an escape sequence, which is this backslash here. That tells it to escape the quote, ignore it inside the programming language, but keep it inside of that string, right? And that is why I use double quotes here when I did that. If I do something like this, I've now got unbalanced quotes. The string is going to end here, and then all of this is going to be stuff that JavaScript doesn't understand, and then it's going to want to start another string. It's waiting for input, which I don't think I'll be able to solve. That would give you a syntax error in a running program. So what I really want to do, we haven't learned about this at all, but I really want to escape that first quote. So now it's like, hey, I'm putting a quote in this string, but ignore it in terms of the programming language. I'm escaping it. And now that works, and that's why it has that sequence in there. So that's an aside. I probably shouldn't have even brought that up, but just so you're aware of it. Easiest way to solve that is to use double quotes, right? And then, so if you want double quotes inside of your string, use single quotes on the outside. If you want single quotes inside of your string, use double quotes on the outside, or escape. Okay. What happens if I assign a new element to my array? Element is another word for the items in the array. Add an index that is way beyond anything that we've used so far. So here's my names. Here's my names.length. What happens if I try to assign, let's say, to the 100th index? So I say names at 100, names at 100 is equal to way out west. What's going to happen here?
Should it just depend to the end of the list?
It's going to add a bunch of like fillers.
It's going to add a bunch of fillers. Yep. And so now, so it's actually appended it, but at the 100th index. And if I look at my names,
Is it the 101st?
it would be the 101st, right? But we refer from 0. So these are all now empty between the beginning of the array and the last item. And if we look at the length, it's now 101, right? So as you're pointing out. But everything in between, so like name, say 99, is still undefined. In a sense, I guess underneath the hood, it's possible that JavaScript grew our array so that it could accommodate having all those extra items. Something else is really going on. It turns out arrays are sort of like objects, and this is really more like a hash or dictionary, but let's not worry about that. Point is, we can do that. We don't get an error, and everything in between remains undefined, right?
And it's empty space, right?
And it's empty space. I don't know, I honestly don't know underneath the hood how JavaScript handles that, if it allocates new memory for it, so we're actually taking up space now, or if it just ignores it. My intuition is that it ignores it, because I believe underneath the hood, JavaScript treats these like objects, and the keys are the numbers. So, because I think I can do that, right? Which looks exactly like an object. Okay, if I want to remove an item, I use delete. So I could say delete names at the 0. That worked. So this is very similar to what we were doing with objects. And now when I look at names, well, it's going to give me a whole bunch of them, but the 0th name is now undefined because I deleted it. If I delete that last one, so I say delete names at 100, and I look at my names, it did not shrink my array back down to accommodate what was there. It just kept all that space for it. So,
can you remove those?
yeah, you can slice your array up. So, and then you would have to delete your entire array. So I got false. Why did I get false? Apparently I cannot delete an array. I did not know that. Do you know how to delete an array? Just overwrite it? Yeah, I would just say names equals empty array, right? Yeah. Cool. So we've got arrays. Arrays are lists of items. We access them by index. Indexing starts at 0. We can stick whatever we want in them, and then we can modify them, we can append to them, and we can delete from them. Very similar to what we can do with objects. And that means that they're mutable. So we have to be careful with arrays. Arrays work the same way that objects work. If we pass an array to a function and we modify that array from inside the function, we have permanently modified that array. So try not to modify arrays and objects inside of your functions. All right. We can create multi-dimensional arrays. So I have an array of strings. I have an array of numbers. I can have an array of arrays. Yeah. Why would I want an array of arrays? What if I wanted to represent a game board that was tile-based? It looked like this. I could treat each one of these things individually as an array that each has 1, 2, 3, 4, 5 items. And then I could treat this whole thing as an array of 1, 2, 3, 4 arrays, right? So it allows me to represent a two-dimensional space, an array of arrays. This is also how we might represent a matrix for linear algebra. We know that the items in an array are just values. They're just data. An array is itself a value, is itself data. So it makes sense that elements of an array could be another array, right? Again, this is that recursive nature of building up things out of the same thing. To make an array of arrays, I open up my array, and then I just add an array to it. So I'm creating an empty array inside my outer array, and that just looks like Greek. We'll see something that makes more sense, but it's basically one array whose first element is an array, right? To make more sense of that, I could have an array of arrays that has some numbers in it to make sure I close it correctly. And so now I have an array that has one element, which is an array, which has numbers, right? So let's make a 4x4 array. I'm going to assign it to a 4x4 equals, and I'm going to use new lines to represent everything. So I'll say 0, 0, 0, 0. So there's one array. That's the first element of the outer array. I need a comma in the right place. Do it again. Comma. Do it again. Comma. And one more time. And then I close my outer array. And now 4x4 is an array of arrays, each 4 elements each.
Is there a shortcut?
You could use a for loop, which we'll actually talk about, but maybe not today. So I don't think we'll get to it. Right? And then to access a cell, so an item inside of this array, well, the first, or the 0th element of 4 by 4 is what? An array, right? So if I want to get to that top right guy, I actually have to use a double array notation. I chain that bracket just like I chain the dot when I'm accessing nested objects. Nested arrays, nested objects, parallel concept. And this is not as crazy as you think. This is a really easy way to represent two-dimensional space, and it has lots of applications. Arrays of arrays are very common. You could have an array of arrays, which would be a representation of three-dimensional space, right? You could have an array of arrays of arrays of arrays and have a hypercube or whatever to some nth dimension. Those become maybe a little less practical and more theoretical, but point is, arrays are things, they're data. Arrays are composed of data, so arrays can hold arrays. Yeah. The recursive nature of programming is sort of like fundamental to the science. Let's do one more concept. And then the rest of this stuff, you know, we're not even going to go over because you can just look it up because the rest of it's not very hard. Iterating through arrays, check the notes, introduces a new for construct. It's a for loop. Check it out in the notes. Look it up in the book, Eloquent JavaScript. But I think you guys can understand that on your own. If you have questions, of course, feel free to ask. And then I introduce some array functions at the very end. So arrays are objects. They have functions. They have properties, as we've kind of seen. There are ways to get access to some special functionality there. So let me cover one last topic here, because it is so common, and then we'll be good. We'll sort of be we'll be caught up a little bit. So a lot of information for one class, but it's good. Okay. We can have arrays of arrays. First of all, we can have arrays of just numbers, and we can have arrays of strings. But then we can have arrays of arrays, and those arrays can be numbers, and those arrays can be strings. So we have arrays of numbers. What else might we want to put in an array? Objects. What else? What do you want to put in an array?
I was thinking about using arrays to store databases.
Not databases themselves, but the results of querying a database is exactly what we'll end up using arrays for in Node. So we'll get there. That is coming up. But a very common use of arrays is to hold on to lists of objects, right? So let's say I've got a person. So var Phil, and Phil's an object. Please don't objectify me. My name is Philip. My age is 32, and my sex is male, right? And now I have this object Phil. I'm not doing this in the REPL so we can see it all. Now I want another object. I want another person. Var, I'll say my brother, James. And my brother also has a name, an age, and a sex, and so on, right? And what if I have 100 persons or 1,000 persons? Well, the good thing about arrays is that we can collect things like these without having to have them in individual variables. We can just stick them all in a single array, right? So it'd be nice if we had maybe an array of people that was composed of objects. So how might we do this? So let's do my brother here, James. My brother is the same age as me for a brief moment. We are adopted, in fact. So let's make an array. I'm sorry, yeah, an array var people equals. I know that my array syntax says it's going to have square brackets, but inside my array, I want these objects. Well, I don't need to reference them by name because I'm actually putting the objects themselves in the array. So I can do that, and I'm going to tab it so we can see that clearly. So what is this? This is an array with a single item. That item is an object. That object has 3 properties. It's just an object inside an array. And then I want to add another object to that array. So I use a comma. And then my next object will be my brother. And I stick him inside that array. And I tab it over. And so now I have an array of 2 objects. So the 0th item, the first item, or first index item. Each object has a name, age, and sex property, right? Yeah?
So those objects are mutable, but the only thing that you can't change about them is their order, like the 0th.
That's right. So the objects themselves can now be changed, but this one is always at the 0th index, and this one is always at the first index, unless I explicitly move them around, right? Yeah?
Oh yeah, what would the advantage of doing it the longhand way that way be over doing it with the variable ways?
If I have 1,000 of these, I don't want to declare 1,000 variables before I stick them in an array. So, and now I can access these things, right? So I have people. I know that the 0th item at people is this guy. It's an object, so it actually will resolve to that object, and then I can use dot notation to get information out of it, right? And so forth. Arrays of objects are used everywhere. So when we talk about getting information back from a database, it comes back as an array of objects. Yeah. And this is extraordinarily handy and is a great way to represent a lot of information in a single variable, people, right? And then you can imagine we'll have these things nested. So it'll be like James has a job that is itself an object with title security at company Devon, say, which is what my brother does. And then maybe actually job itself is an array of his work history inside of that. So I've got arrays that hold objects that themselves have arrays that themselves hold other objects. And I can get very deeply nested complex data structures that are nevertheless relatively straightforward to access. So I could say people 1, so at the 1th index to get my brother, I want to get his job. His job is an array. I want to get the 0th job that's in there, and then I want to get the title. Whoop. Like that, right? So I'm grabbing, sorry if you can't see that, let me scoot it up here. So I'm grabbing the first index from this array, which is this object here. I'm grabbing the job from that object, which is itself an array. I'm getting the 0th item in that array, which is this first object, or a 0th object, and then I'm getting the title in that object, and so on. So we'll get very complex, deeply nested data structures that come back from our databases. Which, incidentally, is what we're building up to. So we've learned about HTML, we've learned about CSS, we're learning about JavaScript. Once we know all 3 of those parts, we will be ready to actually start building the web application, which will probably begin late next week, either next week or the week after. So do please look at the rest of this assignment, or at the rest of this online lesson. You want to understand what a for loop is, and it's good to be familiar with array functions. We did not get a chance to look at our homework over the weekend, but we have another homework assignment, and we will just start class next time by looking over all these 2 days of homework that we have not gotten to yet. Your homework is on GitHub, so go to OK Coders, go to JS Objects Arrays Homework. This is a repository. You can git clone it like you did for the last one, or you can download a zip. Let me show you how this works. I'm going to git clone it, so I'm just going to copy that. I'm going to copy all of it somewhere in the terminal, so I'm going to quit out of here. I'll see what directory I'm in. I guess that's okay. Actually, let's not put it in there. I'll put it in this directory. So I'm going to paste that thing that I just copied from the repository and git clone all that. It's going to download this entire repository so that it's now in a folder, JavaScript or JS Objects Array Homework, so I can cd into that. And I've got 2 files, arrays.js and objects.js. I want to execute those files with Node. So I'll say Node, maybe start with objects.js, and you'll notice that I have 9 tests that are failing. If I look at this file, so I'll Sublime, I'll do subl objects, or just open it up in your text editor, you'll see that there are a series of instructions. Create an object with a name property whose value is Michael. I've given you a template for that empty object. Complete all of these. It's really not as much as it looks like. And then you'll see that I've got tests down here that are actually checking to see if you're doing it correct. And so this code is getting run. You define the things according to the instructions. And when you do it correctly, so let's see what the first one is, create an object with a name property. So I could say name whose value is Michael. Okay. Now if I run my application or that file again with node objects.js, you'll see that test 1 is now passing. The rest need to get done. And you'll want to do that for both of these files, objects.js and arrays.js. And that'll give you some practice with what we talked about today. Keep doing Code Academy and keep reading eloquent JavaScript. Thank you.